Alright, welcome back. We're looking at differentiating exponential functions and the chain rule now. Hopefully you just watched the video on differentiating exponential functions. If you haven't watched this video, go back and watch it. One of the results from our last video though was if you differentiate d on dx, e to the power of x, you got e to the power of x. And e is a mathematical constant. E is 2.71828, etc. So you don't need to know what E is off by heart. The calculator will do E for you nicely. But that is a rule. Okay. Now, that's a function. And e to the x is a function. Sorry. E to the x is a function. Chain rule. Function of a function. So differentiating e to the power of x, while that is easy, if the question says differentiate e to the power of x, your answer is just e to the power of x. But chain rule. So chain rule said dy dx equals dy du multiplied by du dx. So, say we get an exponential function that looks like this. If you have f of x equals e to the x squared plus 4x plus 2, to differentiate that, well, we have a function here, e of a function. So the exponential function, and then my polynomial, my quadratic, my squared function in here. So what I'm going to do, I'm going to come along and let this here be u. Okay, so that means my f of x, well, this is now e to the u, basically. So I might say that y equals e to the u. Dy du is e to the u. Okay, that's my exponential rule. Differentiate it, you get the same thing. And then, if I have u equals x squared plus 4x plus 2, du dx is equal to 2x plus 4. And then putting these together using my chain rule. Chain rule, I'll leave it there. Dy dx is equal to dy du, so dy du e to the u multiplied by du dx, so du dx is down here, 2x plus 4. And to tie that up a little bit, get it all in terms of the question, f dash x is equal to 2x plus 4, e, and e to the power of u, you should recall is x squared plus 4x plus 2. Okay, that's just one application using the chain rule. Just for notation, we'll say let y equal e to the u, and then it's following nicely HSE standards. All right, so looking at our question, looking at our answer, what we have here, we have differentiated f here. So f, we started with f, we ended up with f dash x. This last bit here is actually the same. So that there is the same as this here. Okay, so that is f of x. So what we can say for a rule, if you differentiate d on dx, if you have e to the f of x, that's not very nice for notation. I'm going to change it to be g, just to make it a little bit clear so we don't get confused with our question. E to some function, g of x. Then when you differentiate that, you get the derivative of that function, g dash x, and then e to the g of x. And you can see that happening in our above scenario. So f of x here, our starting function, we've got e to something. What we do, we differentiate that there, put it out the front. So differentiate x squared plus 4x plus 2, that becomes 2x plus 4, that comes out the front. And then we have the same thing we started with. We started with e to some function, e to some function in our end here. So this actually is a rule as well. You will normally see it expressed in terms of f. I'll rewrite it for you below in a second. That one is important to know. And we'll do a bunch of examples in the next video just to really reiterate that. But the rule says, in terms of f, d on dx, e f of x equals f dash x e to the f of x. That should be in brackets there. Okay, so chain rule, our good old friend happening there. What we're doing, differentiating the power, differentiate that, put it out the front. And then multiply by e to the f of x in the end as well. That's the chain rule for exponentials. Like I said, we'll do some examples in a minute on another video. Thanks for watching.